Yes, thank you very much. It's really nice to hear that you also ran a mobile Fab Lab. Um, okay, so I'll share my screen. Okay, can you see the slides? Okay, perfect. Um, my name is Burak, and I'm an industrial designer and maker. Um, I am originally from Turkey, but I've been living in Helsinki for 3 years. I came here to do my master's in new media. I graduated in 2024, and since then I've been working here doing design, prototyping, and also I've been running workshops and lessons on how to use the digital fabrication for art and design. So today I'm going to talk about my um, in which I designed, built, and tested a mobile makerspace for children's education. So I'll start by going over the whole process and sharing my learnings from the process, and then hopefully leave you with some concrete ideas and strategies so that you might try to implement on your own. So let's start with what are mobile makerspaces. I just define them as makerspaces that move. They can range from like modified trucks that cover long distances to a simple cart that just moves around in a single school building. The goal of my thesis was to create a proof of concept for a mobile makerspace that would operate in Finland's Uusimaa region. And Uusimaa is the region that has like the capital Helsinki and the area around it. And the primary use case was to provide maker education to children through digital fabrication tools. Um, so I started with background research. I interviewed makers, educators, and then I analyzed my findings to move on to design and prototyping. I designed the physical component and an educational component for this mobile makerspace. And then I tested both components in a test workshop. I'll start with explaining the background research. So my interviewees were mobile makerspace workers, so like Fab Lab employees, managers, people who design mobile makerspaces, and also maker educators. So people specializing in electronics art, robotics, digital fabrication, etc. With the mobile makerspace workers, I mainly talked about the physical design of their makerspaces, how it goes from point A to point B, and what it's used for. And with maker educators, I mainly talked about their educational strategies, what they teach, and like how they teach it, how they organize it. I then analyzed my findings. So these analyses both served to present the different ways people engage with mobile maker spaces and like maker education, but it also served as a blueprint for the mobile maker space that I was designing. So the first theme that I analyzed was mobility strategy. I identified three distinct ones from the 6 people I interviewed. Um, so the first one is a modified van as both a transportation device and the space for the activity itself. The second one was a dedicated van used for transportation, but the activity was held in a school or a library, so a separate space. And then the third one was that the transportation was made by a shipping company while the activities were held in a separate space. For my case, I went with the second option, to have a dedicated van, but to have the activities in a separate space. And there was three distinct use cases as well. There was children's and public education, publicity and marketing for the Fab Lab, or like the main makerspace, and also hobby use. And again, my use case was children's and public education. And for the educational strategies, I outlined six distinct principles. These also acted as guiding principles while I was designing the educational component of my makerspace. So the first one is process over product. So as we know, trial and error is quite a central part of maker education. Like in electronics art, for example, it's very common that your artwork doesn't like work. So it's important to create a safe space for failure and also normalize that the troubleshooting is part of the process. And one way to do it is, of course, to focus on the process rather than the final polished product. Also, so the second one was the duration and the age influence the content. And in my case, I basically had my target group as age 10 and 12. And the duration of my workshops was going to be 3 to 4 hour introductory workshops for beginners. But if you have these short workshops for beginners and you want to focus on experimentation, then the question becomes how to give design freedom within this confined space, which brings me to my third point. Like, of course, experimentation is very important in maker education. So rather than following tutorial-like workflows where at the end everyone has the same thing, it is important to let people experiment and fail and so on and so forth. But within these small times and with an age group with no experience, how can we actually provide this design freedom? So this was one of the central questions that I tried to solve. The fourth strategy was about demystifying technology. So digital fabrication machines can be quite intimidating for beginners. And when the sole focus is on learning to use the machine can become this indispensable, like black box, a scary object we're afraid to break. So in the workshops that I was designing, I aimed to keep the machine in the background and you view it merely as a tool for the participants to create their custom projects out of. The fifth one was about inclusivity for beginners. So I aimed to not basically alienate any groups or people from non-technical backgrounds, or like people that are sadly sometimes often alienated from makerspaces due to socioeconomic background, cultural background, technical background, things like this. So I aimed to that my educational component would prioritize also inclusivity. And the final one was grounding teaching on familiar concepts. So to explain abstract concepts such as vector versus pixel, I used metaphors and things from the daily lives of the participants so they can understand better. So now I'll move to the design and prototyping. As I said, the mobility strategy that I designed was around using a dedicated van as a transportation method, and then holding the activities at a separate space. So I decided I would design these cabinets that the machines would go into, but also would work as workspaces. So these cabinets would be loaded into a van, taken to a school, and then the school's premises would be used, the classrooms would be used to hold the workshops, basically. And these cabinets would act as workstations. I collaborated with Aalto Junior, which is the Children's and Youth Education Center of Aalto University in Helsinki. And they provided the funding to buy the machines and also the materials, and they also provided me a space to test the idea, which was in their summer school for 10 to 12-year-olds. So the design process started with sketching and 3D modeling, and then I moved on to CNC machining these cabinets out of plywood. I assembled them, and then here you can see the two cabinets, one for the laser cutter, one for the vinyl cutter. And as you can see, the idea was that the lid of these cabinets would act as workspaces. So you can put your computer, you can put your materials on there while you are working, and the bottom would also act as a storage space. And then these boxes would close up and then be loaded into a van. So these are from the mobility tests that we did after I assembled the cabinets. And then I moved on to designing the educational component, which would be a workshop that would be held with this mobile makerspace. The idea was to design these little like model houses, but of course, I didn't want them to be the same for everyone. You know, everyone follows a tutorial workflow and gets the same thing at the end. I wanted some customization there, some experimentation. But how to do that with a design this complicated? I used this browser-based vector editor called Cuttle. So as you can see here, this is a parametric design software. So when you change you can make models so that, for example, you change the width, the height, the roof height, etc. The rest of the model basically adapts to it. And by this, you can basically change the size and shape of your house. You make sure that still it can be put together, and the children skip the boring part of doing the finger joints, and they can actually focus on, you know, actually designing the house, doing the customization. They can put the windows, the doors, the engravings on it, and so on and so forth. And then we tested both the physical and the educational component in the test workshop. So it looked like this, the workshop area. Everyone had their had a laptop for them, and we had these like tiles in front of them. And the idea was that everyone would design their house and then bring it together in these tiles, which had forests and like rivers and stuff. And then at the end, everyone's tiles would come together to form a little village with all the houses. So I first explained to them how to use the software, how to do the design, and then we went over to laser cutting, and we cut all of their designs. Then they assembled them themselves, and afterwards we also used the vinyl cutter. So they designed some stickers to stick on the houses. And at the end, we brought all of their houses together to form our village. So we got quite a lot of variety. Like we had some like huts, we had, you know, bakery, office building, pet shop. We had a pizzeria. Some of them like painted their houses. As you can see, some of them did different customizations. Some of them like stuck some like with glue. They stuck some other parts onto the house. Some of them used these like outcuts from the laser cutting to make these like little ships for the river, for example. So we got quite a lot of variety, and at the end, they got to take the houses home as well. So to move over to the discussion part, I'll first start with the design features. So I used a parametric CAD software to design these boxes. So that made it things quite easy to design for different machine sizes quite fast. So I designed two, one for vinyl, one for a laser. So that worked quite well. Some of the design features proved quite useful in the test workshop. For example, the doors of the cabinet opening to the side and forming a work surface was very useful during the workshop. Also, having the storage space underneath. And one nice thing that I actually didn't think of before was that it was good that the cabinets were low so that the children could actually see what's going on. They could actually see inside the laser cutter. The mobility strategy that I had low initial investment, so you don't need to buy a van and modify it. It was flexible in transportation, so you don't necessarily need to have a van. Like you can rent a van, or you don't even sometimes need a van. You can put these to a metro and then go as well. One thing that we couldn't test was the machine's safety during the transportation, because the machines belong to the partner organization. They didn't, and they were going to use it after, so they didn't want to potentially damage it. So that was one thing that we couldn't test during the process. The vinyl cutter worked good. It was easy to carry and good for our participants. The laser was compact and it performed well, but ventilation might be a challenge if you are looking to replicate this. We did our workshop in like the space was an old chemistry lab, so they already had ventilation hoods. So we just vented from there. But if you are gonna do that, you should look into getting mobile filters, or even better yet, after the filter, like put the hose out of a window or find some alternative ventilation solution. And for the educational strategies, Cuttle worked very well. So it kind of solved the issue of design freedom in a short time with a beginner group by using parametric design. Role-playing and play elements also gave quite interesting results. So for example, in the beginning, I told them, like, you don't necessarily need to make a house, but you can make think of what you want to be in this village that we will make, like a baker, librarian, restaurant owner, and you can make that building. And that got them quite excited, this ability to role play. And I also found that it is good to have like time and instructor availability for troubleshooting. So we had, of course, a few ones that we needed to recut. So that would definitely be good to be part of the plan. And I included both the laser and the vinyl cutter, but I found that this kind of divided the group, because once we assembled the houses and moved on to vinyl cutting, some kids were like, no, I'm okay. I don't really want to do vinyl cutting. So we kind of divided the group, and some played some, video games, and some of them did vinyl cutting. So if I did this again, I would probably focus on one process. And having additional helpers was quite important, especially a teacher that has worked with the group before helped a lot. And also the needs of the target group should be taken into account. For example, the need to take a break, play, and such. So for the next steps, I'm remaking these cabinets in free design software in FreeCAD. And like I'm making them parametric, so people can actually take them, and without doing any like 3D modeling, hopefully you'll be able to change these models, get a output, and then either using a CNC or like a jigsaw make your own. So I aim to make them publicly available and open source. And I will continue the mobile makerspace project in Helsinki if there's enough funding. Okay, well, I guess we're ending. But yes, if you would like to connect, please do so. Feel free to send me an email or follow me on LinkedIn or GitLab to get updates when I release the cabinet designs. You can find the parametric house design here in the Cuddle link, and you can scan the QR code to get in touch. Yes, thank you very much.
Thank you, Burak.